afternoon, students. Today we want to discuss organic chemistry. And under organic chemistry, we normally have what we call hydrocarbons as a subtopic in organic chemistry. Organic chemistry deals with hydrocarbons. So maybe you may know how to define the term organic chemistry. So we normally say organic chemistry is a branch of chemistry that studies carbon compounds present in living things. The carbon compounds, and also you can talk of carbon and hydrogen present in living things, but basically carbons. So here we need to know what we call hydrocarbons. Hydrocarbons as a subtopic in this organic chemistry. So very first, hydrocarbons, these are compounds that composed of hydrogen and carbon. So it is basically hydrogen and carbon. So you might be asked to define the term hydrocarbons. These are compounds that composed hydrogen and carbon are the only constituents. So these hydrocarbons, depending on the type of bond that exists between the individual carbon atoms, hydrocarbons are classified. So it depends with the type of bond that exists between the carbon and carbon atoms. So these hydrocarbons are classified into three, depending on the type of bond between carbon and carbon atom. So we normally have what we call alkanes. Then we also have alkenes, then alkynes. So for the alkanes, we normally have what we call a covalent bond in between the carbon atom. Then for the alkenes, so like for example, in the alkenes, we normally have what we call a single bond between carbon and carbon. Alkenes, we have a double bond between carbon and carbon atoms. Alkynes, we have a triple bond between carbon and carbon. So that is now the breakthrough of these hydrocarbons. So they are classified into three, depending on the number of covalent bond between the atoms. So we want to go further and discuss about alkanes. So in this topic, we'll discuss about alkanes and nomenclature of these alkanes. So we go and discuss about alkanes. So alkanes, these are hydrocarbons with a single bond between carbon and carbon atom. So here we need to know what we call a single bond between carbon and carbon atom. And this carbon is surrounded by a number of hydrogen. For it to be stable, it needs to be surrounded by a number of hydrogen. And normally have what we call four bonds that need to surround that carbon. Four bonds. Like for example, this one, carbon to carbon, it has what we call hydrogen bonds. So as you can see, it has four bonds. Have 1, 2, 3, 4. It's attached with the hydrogen on the other sides. For it to be stable, it needs to be bonded to 3 hydrogen and another carbon. Also, we also have an alkane that has only 1 carbon, and that is methane, which is also surrounded with the 4 hydrogen atoms. As I said earlier, that this carbon must be surrounded with 4 bonds for it to be stable. If it is less than 4 bonds, it cannot be stable. So that is it. So these are hydrocarbons with a general formula CnH2n+2. So the general formula of alkanes, general formula of alkanes is CnH2n+2. So this is now the general formula of alkanes. So where N is the number of carbon atoms, N is the number of carbon atoms. Like for example, these carbon atoms are linked by a single bond to each other, and to the hydrogen atom. So like for example, they might ask you to, though they cannot ask you to write the formula of an alkane. That is a simple question that you don't expect to be asked. You need to be asked very challenging questions for you to make your minds wide. So we normally have examples of alkanes. Examples like, for example, an alkane that has 5 carbon atoms. 5 carbon atoms, that is pentane. Pentane. So if it has 5 carbon atoms, this is now the general formula. We normally have here C, 5, then H. We said that N is the number of carbon atoms present. So 5 carbon atoms. So it is now 5 times 2, then plus 2. That is 10. So this is now the molecular formula of an pentane. We normally have another one. We can talk of butane, which is now 4 carbon atoms. That is C4H, 4 times 2, that is 8. Here it is, this is 5 times 2, that is 10, then plus 2, that is 12. Sorry for that inconvenience. So here it is 10. So this one is butane, and this one is pentane. So that is how you know how to write the molecular formula of these alkanes. You just try this, the molecular formula, and ensure that you know this, the general formula of this alkane, because some examiners they might just ask you to write the general formula of alkanes. The general formula of alkane is CnH2n plus 2, and I have given you the examples on how to calculate that one. Then you want to move further to nomenclature of alkanes. Nomenclature of alkanes. Nomenclature of alkanes. Nomenclature. So for the nomenclature, this is now the building block of this topic, because these steps, nomenclature just means naming of these alkanes. How will you name an alkane? Like for example, when they draw for you a structure, how will you name it? So that is what you call nomenclature. And this is now the building block whereby you need to know the rules. You normally have the rules that normally guide you how to name these alkanes. So just a minute, I give you the rules. Pause. So nomenclature of alkanes, the first one is identify the longest continuous carbon chain. Is to identify the longest continuous carbon chain. That is the first rule. The first rule is to identify the longest continuous carbon chain. Like for example, they can draw for you this structure here. Like for example, this one. Then you have hydrogen there, hydrogen, 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 hydrogen. Then maybe here you have what you call a branch, CH3. So for you to identify the parent name of this structural formula, I will give you the definitions of structural formula, molecular formula, and also the content formula. You might get those questions. So this is now the structural formula. The structural formula. It shows the arrangement of atoms. It shows the arrangement of the atoms between carbon and in a compound. Let's say arrangement of atoms, for example, the arrangement of hydrogen in this compound. So this compound, we start by identifying the longest continuous carbon chain. So you have 1, 2, 3, 4, 5. So you have 5. You cannot go this way because you have 1, 2, 3, 4. This one is short. 1, 2, 3, 4. This one is short. So the longest continuous carbon chain is from here up to here, which is 5. And 5, it is pent. So the pent name here is pent. Pent. So the name of this structure. Then remember we have a branch here, though. So we have a methyl branch here, a methyl. So like for example, when this is methane. Methane is CH4. So when you remove one hydrogen atom, it becomes methyl. Methyl. So when you remove one hydrogen atoms here, it now becomes, so this one is methane. When you remove one hydrogen CH3, it becomes methyl. Methyl. And this methyl is now a branch here. This is now a branch. It is attached to a carbon. Any compound attached to a carbon, that is a branch. Any compound or any halogen or a halogen atom attached to a carbon, that is a branch. So this is a methyl. When like for example, pentane is CH, C5H12. When you remove one hydrogen, it becomes pentyl. So it is C5H11. So these are pentyl. Like for example, for then ethane, C2H6. When you remove one hydrogen, it becomes an ethyl. So so maybe a branch here, it might be attached here. Here it will be 2. Here 5. That it means that is a methyl. So when a hydrocarbon is less by one hydrogen, it becomes an I. Like for example, then you remove one hydrogen, it becomes a methyl. When you remove one hydrogen to pentane, it becomes pentyl. When you remove ethane, one hydrogen, it becomes an ethyl. So that is now a breakthrough of what we shall be doing in branches. So branches, it is I. So like for example here, it is, so this branch is attached to carbon number 3. So the naming of this this compound, it will be 3-methyl pentane. 3-methyl pentane. So because the methyl group is attached to carbon number 3, so when you start from this side, you have 1, 2, 3, 4, 5. And remember, you have a dash here. When you are separating a number by the name, you have a dash. When you're separating a number by a number by a number, you have a comma. We shall do very many examples. So that is the first rule. You identify the longest continuous carbon chain, which will give you the parent name. Like for example, here is 1, 2, 3, 4, 5. The parent name there is pentane. Then you identify the branch. Then number 2, the number of the longest chain form the end of the chain that is near to the branches, so as the branch gets the lowest number possible. So number 2, you count the carbon, the longest carbon chain, as when you have a branch such that the branch gets the lower number possible. Like for example, you have a case of let's say this is 1, 2, 3, 4, 5, 6, 7. So we have here a branch. We have here a branch. Let me put here. We have a branch here. C2, H5. Then of course we have hydrogen on the other side. So the second rule is that you start from the side of the longest continuous chain that should give a branch the lowest number possible. Like for example, in this case, when you start from here, 1, 2, 3, 4, 5, 6, 7. You can see you are giving the branch a number which is more than the expected number. And like when you start from here, when you start from this side, 1, 2, 3, you can see the branches attached to carbon number 3. So it is better you start from the side that gives the branch the lowest number possible. You start from the side that gives the branch the lowest number possible. So in this case, you cannot start from this point here. So you start from this point, because when you start from this point, the branch will be attached to carbon number 5. But when you start from this point, the carbon will be attached to carbon number 3. So the rule here is you start from the side of the longest continuous carbon chain that will give a branch the shortest number possible, or a smaller number possible. Now for this case here, the longest carbon chain 1, 2, 3, 4, 5, 6, 7. So it is hept. The parent name is hept. And since it's an alkane, you just say heptane. Then you come and identify where we have the branch. And keeping in mind, this is 2 carbon, and 2 carbon, that is ethane. We have removed only 1 hydrogen, because ethane is C2H6. So when you remove 1 hydrogen, is ethyl. So here it is from 1, 2, 3. So that one will be 3 ethyl heptane, and you get a mark. When you mess, you will fail. And ensure that when you are separating a number and that compound, ensure that you separate by a dash. When you're separating a number by a number, use a comma. We shall do very many examples for you to better in. So that is the second rule when naming this alkane. Pause. Rule number 3, determine the position, stroke number, and the type of the branches. Name them as methyl, ethyl, propyl. That one I has taught it. That rule, I has taught it 2 minutes ago. Then another rule, use a prefix, di, tri, tetra, pent. Then also consider the alphabetical order. Now, rule number 3, use prefix like di, tri, if you have more than 1 branch. Like for example, we have here a compound. I'm using structural formulas because molecular formula, you need to have more content before you start using the molecular formula. So let's just use the structural formula. So like for example, here you have 1, 2, 3, 4, 5, then 6. Then of course, we have here what we call a branch. We have here a branch that is CH3. Then you have here a branch CH3. Then of course we have hydrogen atoms. I have hydrogen atoms. Now for this case, we need to know the first rule, continuous carbon chain. The second rule, from the side that will give that will give the branch the shortest number possible. Then the third rule, use prefix like di, tri, if the branches are more than 1. So for this case, we have 2 branches. In our case, we shall just start from here, because we shall give a method. The branch will have the shortest number possible. So this one is hex. 1, 2, 3, 4, 5, 6. That is the longest carbon chain. That is hex. That is hexane. Now for this one, we have 2 branches. We have 1, 2. So the first branch attached to carbon number 2. So you will say 2, comma. The second branch is attached to carbon number 1, 2, 3, 4. Number 4. Then I say that when you're separating a number by a number, use a comma. When you're separating a number by a compound, use a dash. So when you use a prefix, it will be now di, because it is this and this. So you use di, methyl, hexane, and you get your mark. Then so that is it. Then rule number 4, that one was rule number 3. Rule number 4, you consider the alphabetical order depending on the substituents. Substituents are just branches. substituent are just branches. I said that we have substituent for the substituent for halogens and substituent for the ions from the compound itself when you remove a hydrogen. So use alphabetical order. So the fourth one, consider the alphabetical order of the branches, or you can talk of substituents. Substituents are branches that are the same. For example, I have a compound here. Then we here have bromine. Here we have iodine. Then here we have, of course, we have hydrogen. Then here I have let me use here another bromine here, or let me just put here an ethyl, because that is what they normally use, mostly ethyl. Then we have here chlorine. Then finally let me put here another bromine here, another bromine there. Then let me add here another branch. Now this is now a complex structure which you need to tackle it with a lot of keenness. Failure to that will fail. So for this case, first of all, you identify the longest continuous carbon chain. And the longest continuous carbon chain, you need to know where you should start from. Like for example, when you start from this side, you will not start from here. When a methyl group is attached to the first carbon, that methyl group is considered to be in the longest carbon chain. You will note that one. When a methyl group is attached to the first carbon, that one is not a branch. It is considered to be in the longest continuous carbon chain. So when you want to find the parent name, you will not start from here. Or when you start from here, you will not end here. You will end here. Or when you start from here, you start from here up to here. So that is the rule that you need to know here. When a methyl group is attached to the first carbon, that one is considered as a carbon in the longest continuous carbon chain. It's not a branch. Then the second rule was that ensure that when you start naming, when you want to identify the parent name, ensure that the substituent or the branch will get the lowest number possible. Now, when you start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is 1, this one is 2, this one is 3, this one is 4, this one is 5, 6, 7, 8, 9. Then when you start from here, that is now 1, 2, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I think my work is clear. So when you start from here, you can see the first branch is on carbon number 3. But when you start from here, the first branch is on carbon number 2. On carbon number 2. So we shall now start from the right hand side, because the first branch is on carbon number 2. That's where we shall start from. So we'll start naming this compound from the right hand side. Start counting it from the right hand side. So we'll start now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one is none. Nonen, because it is that is now the parent name, nonen. Number 9, nonen. Then we need to consider the alphabetical order of this substituents. Like here, so you have number 1, number 2, number 3, number 4. So iodine is attached to number 4. Bromine, 2 bromines are attached to number 6. Then chlorine is attached to number 7. Now, so here we are going to start with bromine because B comes before C comes before I. So here, bromine, we have 2 bromine on carbon number 6. So we are going to say we have 6, 6 because we have 2 bromine. 6, 6. And remember here we are now separating a number by a number. Then dash dibromo. Because you have how many bromine? 2 bromine on carbon number 6. So you say 6, 6 dibromo. Then the second one is C. So from B you go to C. That is now chlorine. Then you separate this one by a dash. Then chlorine is attached to number 7. So you say dash 7. Then chloro. Then we have iodine on carbon number 4. Iodine on carbon number 4. You also separate that one 4. Iodo. Then we have a methyl on carbon number 2. Then you come and say you separate the dash 2. Then methyl. Nonene. You can see that is how we name this structure. And this one is rule number 4. The alphabetical order. Bromine comes first. Bromine comes before chlorine. Chlorine comes before iodine. So 6, 6 dibromo. You have used a prefix di. Tri. If it is 3, use tri. If it is 4, use tetra. If it is 5, use pent. So that is dibromo. Then number 7 you have chlorine. The second alphabetical order is C. So 7 chloro. Then dash 4 iodo. 2 methyl nonene. Remember, a number by a number is separated by a comma. A number by that compound separated by a dash. If you fail or if you forget to separate, you forget any dash or comma, you are going to fail everything here. So ensure that you are keen when you are naming these compounds. So that is rule number 4, and that one I think is the last one for the alkanes, nomenclature of alkanes. So just a breakthrough. So the first rule is you identify the longest continuous carbon chain. Identify the longest continuous carbon chain, and that longest continuous carbon chain will give you the parent name for that compound. As in this case, have no name. Number 2, you identify or you start counting from the side that will give the branch or a substituent the lowest number possible. For this case, when you start from this one, the first branch is number 2. So when you start from that side, it will give this branch the lowest number possible. You cannot start from this one. And also, when a branch or when a methyl is attached to carbon to the first carbon, that methyl is considered in the continuous carbon chain. That methyl is not a branch. Even ethyl, when it's attached to the first carbon, we have 2 carbon on that in that ethyl, so it will be considered in the longest continuous carbon chain. Or a propyl, when it is attached to first carbon, it is not a branch. That is rule number 3. Rule number 4, you use rule number 3, use prefixes. Like for example, di. When you have 2 bromine, use dibromo. When you have 3, use triiodo, dichloro. That is it. Then number 4, you ensure that you consider the alphabetical order. Bromine, when you have this substituent, bromine will come for the first one. chlorine comes the second one. So ensure that you follow the alphabetical order and the way the substituents are. And very many things we'll discuss on the alkenes and alkynes. Then maybe I might be forgetting something here small. Maybe we have two branches of ethyl and methyl. You also consider the alphabetical, like for example, we have this compound here, 1, 2, 3, 4, 5, 6. Then we have here an ethyl group, an ethyl. Then for this case we have a methyl group. Then of course we have carbon atoms on each side. So for this case, ensure that you count the longest continuous carbon chain. Then for this one now, you will start from here, 1, 2. So ethyl, this is an ethyl because it has 2 carbon, and methyl. Remember very well that E comes before M. So you will start with ethyl, not methyl. I think I'm communicating. So this compound, the parent name here is hexane. The parent name is hexane. So this one is, so ethyl is a number, so it is 2 ethyl. Then 1, 2, 3, 4, then 4 methyl hexane. I have considered the alphabetical order. So ensure that when a question comes on naming or nomenclature of alkanes, ensure that you follow the rules for you to be in position to answer those questions very well. So when you follow those 4 rules and those 4 steps, and when you are keen, you cannot fail. Then keep in mind the dashes. A dash is separated by a number and a compound. Then a comma is separated by a number and a number. A number by a number. Keep that one in mind. You will not fail that question. Now, so we normally have some terms in this organic chemistry or in this hydrocarbons. You have come across the terms molecular formula, structural formula. Maybe you don't know how they mean, but I'm not saying that you'll be asked an exam, but you just know how they mean. So like for example, molecular formula of a compound shows the number of each atoms of elements making the compound. Molecular formula, it shows the number of atoms or compound, the number of atoms of elements making the compound. Like for example, this compound here, we have C2H6. So this is the molecular formula of ethane. So ethane, it has 2 carbon and 6 hydrogen. So that is a molecular formula. And you can see that this molecular formula is showing the number of atoms of the element making the compound. So this is an element. This is an element, this is an element. So when you combine it, that's a compound. So these 2 atoms of carbon, 6 hydrogen atoms. So when you combine, that's a compound. So the molecular formula, it shows the number of atoms of the element making a compound. Then I say that the structural formula, structural formula. Now this one, it shows the arrangement of atoms or bonding between the elements in a compound. Shows the arrangement or bonding of atoms of each element making the compound. Like for example, when I write this one, C, then I put there hydrogen, 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 hydrogen. So it shows the arrangement of atoms or the bonding. So this is a bond, a bond, a bond. So the bonding of each atom of elements present in a compound. So that is the structural formula. It shows the arrangement, how these atoms are arranged or are bonded, this of the element in that compound. So that is a basic thing that you need just to know, just to understand. Though you might not be asked in high school, but in advance, Maybe when you go in campus, when you do chemistry, you'll be asked to define structural formula, molecular formula, condensed formula. In a high school, you normally say that condensed formula is just a simplified way of molecular formula. Like for example, when you break this this ethane, when you want to write in as a condensed formula, that is now an ethane. Ethane in condensed formula, you'll write C. It's attached with 3 hydrogen. Another C is also attached with 3 hydrogen. That is condensed formula. Maybe in an exam you might be asked a question, then they ask you to write the final answer in a condensed formula. So the condensed formula is a simplified way of structural molecular formula. Like for example, let's say pentane. So the molecular formula of pentane is C5H12. So when you break this one, when you break this pentane, it becomes a condensed formula. So the pentane will be CH3, CH2, CH2. So you need to note the number of hydrogen. So the first one is 3, 2, 2. That is 7. Then CH2, CH2. 7 plus 4, that is. So here it is CH3. So 1, 2, 3, 4, 5. This one here is CH3. So when you want to combine it, so this is now the condensed formula of pentane, but you can write in another way also. You can write as CH3. Then this carbon here, you will say you have how many carbon here? 1, 2, 3. 3 carbon. So you will say C3. Then you put in bracket the number of hydrogen atoms. This is 2 plus 2, that is 4 plus, that is 6. 6. The number of hydrogen atom, then CH3. This one is hydrogen atoms here. 6. Like that. So that is now the condensed structural formula of this compound. So in an exam you might be asked to maybe write the final answer in the molecular formula. Write the final answer in a condensed formula. That is how we write the formula of this compound, as the structural formula, molecular formula, and the condensed formula. That is a basic knowledge that you need just to know for the explanation of that compound. Then these compounds, they normally differ. This compound, they normally differ by a CH2 group. They normally differ by a CH2 group. For example, when you move from methane to ethane, we have a difference of CH2 group. So like for example, methane is CH4. CH4. When you go to ethane, it is C2H6. You can see there's a difference of 2 hydrogen and also 1 carbon and 2 hydrogen. A difference of CH2 group. Remember, we say CH2 group. Also, when you move to propane, you will add CH2. When you move to butane, you will add CH2. Like for example here, propane. Just see propane, you are adding another C3 and H8. You can see we have added 2 hydrogen, 1 carbon, 2 hydrogen, 1 carbon. When you move to butane, we add another carbon and another 2, that is 10. When you move to pentane, C5H12. So this is what we call homologous series. This is what we call homologous series. So so you normally say you might be asked to define a homologous series. So a group of compounds that differ by a CH2 group from the next to the previous consecutively or consistently is called a homologous series. So a group of compounds that differ by a CH2 group from one compound to another, that one is what we call a homologous series. And this is a common question in high school. You might define the term homologous series. Homologous series is a group of compounds that differ by a CH2 group from one compound to another consistently. Consistently means means it is now the number in between one compound and another one is the same. In between is the same. It's defined by the same number. So a group of compounds that differ by a CH2 group from one compound to another consistently is what we call a homologous series. I think I'm clear. So that is also a common question that you need to know. What to define homologous series. To define homologous series. So thereafter, and this is also a common question on exam, to give the properties of this homologous series. The properties of homologous series. So the first one, from the definition itself, the first property of homologous series. Properties of homologous series. Take note of this. This is an exam question. It normally comes 3 marks. You give all the properties of homologous series. So number one, they differ by a CH2 group from one to the next, consecutively or consistently. So they differ by a CH2 group from one compound to the next consistently. That is the first property. When an equation comes in the exam, give the properties of homologous series, you say they differ by a CH2 group from one compound to another consistently or consecutively. Consecutively is the same as consistently. Here they're just using hard terms to confuse you, but they're the same. Then they have similar chemical properties. That is another one. They have similar chemical properties. So some of you here, they do confuse between chemical properties and physical property. Physical property is the one that you see with your naked eye. But chemical property is the one that you test. You need to test. Like for example, when you burn methane in oxygen, when you burn this compound oxygen, it produces carbon dioxide and also water. When you burn this methane or propane, so that's a chemical property. They have the same chemical property. They have the same chemical properties. Also, their boiling point increases as the number of carbon atom gets longer. Their boiling point and also melting point increases as the number of carbon atom gets longer. That's also a chemical property. So they have the similar chemical property. Also, the method of preparation is also the same. They have the same way of preparing. You can prepare propane the same way you prepare methane. That's a chemical property. So they have the similar chemical properties. Then number 3, they have similar chemical formula that can be represented by a general formula, Alkanes. So they have the same, they have similar chemical formula, So for you to earn the full mark, you write this, the chemical formula. That is CnH2n plus 2. Then you get a mark. That is the formula that you can use to find these alkanes. They have similar chemical formula. That is another property of homologous series. Then I just want to give you 4, which are simple Then also another one is the physical properties. The physical properties shows a steady gradual change as the chain gets longer. Previously I have said that the physical properties is the one that you can see. Like for example, boiling and melting points are physical. It's not a chemical property, it's a physical property because you can see when it starts boiling or when it starts melting. So they have the physical properties, that is number 3. Physical property shows a gradual change as the chain gets longer. As the chain gets longer. Like for example, the melting point increases as the chain gets longer. And you'll have to explain. You might be asked in an exam, give a reason why the melting point of methane is lower than the melting point of propane, or give a reason why the melting point of ethane or the melting point of butane is higher than the melting point of ethane. You need to explain in terms of bonds, and the structure. Like for example, the melting point of ethane is larger than that, lower than that of butane, simply because the number of bonds between ethane is much smaller than that of butane, because when the chain gets longer, the number of bonds increases, and therefore the energy or the heat that's required to break that bonds also increases. And that's why we are saying that the physical property shows a gradual change as the chain gets longer. And that gradual change, it means that it is increasing as the chain gets longer, because because of the bonds between the carbon and carbon, or carbon and hydrogen atoms being increased. So these are now the 4 properties of homologous series, and it is a very common question of which most students normally fail due to lack of revision and also lack of being attentive in class. The way I have explained how homologous series comes, the way I have explained the physical property, the properties of homologous series, I think a student cannot fail that question when it comes to an exam. So ensure that you follow whatever I'm telling you. Both. Isomers. So let's move to isomers of alkanes. Isomers of alkanes. So this is now a common question in an exam, whereby you are always be asked to define what the definition of isomer. So what are isomer? Isomer, these are compounds with the same molecular formula but different structural formula. Let me write. These are compounds with the same molecular formula but different structural formula. So that is what you call an isomer. An isomer, these are compounds with the same molecular formula but different structural formula. For example, this compound here, let's say we have a compound like I said that these are compounds with the same molecular formula or general formula but different structural formula. Like for example, let me use an example of butane. Of course, we have branches there. Then here we also have another one. Let me put here a branch. Let me put there a branch. So the molecular formula, so this one Then you have another one here. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. So, like for this case here, the structural formula is different. The structural formula is different. You can see this one. This one is the name is pendant. This one is the name is pendant. But this one, the name is 2-methylbutane. 2-methylbutane. So when you write the molecular formula of this compound and this compound, the molecular formula are the same, because when you count the number of carbon here and the number of carbon here and hydrogen here are the same. So like for example here the number of hydrogen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The molecular formula of this compound is the same. The molecular formula now, for the example here, carbon 1, 2, 3, 4, 5, C5H12. Here also the number of carbon is C, it's the same, and also. So the molecular formula of this one and this one is the same. But when you see the structural formula is different. The structural formula of this one is not the same as the structural formula of this one. And that's why the name differ, but the molecular formula is the same. The name of this one is 2-methylbutane, but the name of this one is pendant. And the molecular formula is the same as this one, but the structural formula is different. So this one is an isomer of this, and this one is an isomer of this. So pendant is an isomer of 2-methylbutane, and 2-methylbutane is an isomer of pendant. And that's why you're saying that these are compounds with the same molecular formula, but different structural formula. I think that one I have elaborated well. That is now what we call an isomer. Another part is isomerism. So what is now isomerism? So they normally ask you differentiate between an isomer and isomerism. So the existence. So the difference between isomer and isomer. So isomerism, you need to study the term existence. Existence, the existence of atoms or compounds. So if there's not the word existence, you fail. So isomerism is the existence of compounds having the same molecular formula but different structural formula. So it's just a matter of adding what you call isomerism. So the existence of compounds having same molecular formula but different structural formula. So that's what you call isomerism. Relying the term existence, only that one. So in an exam, they normally ask define the differentiate between isomer and isomerism. So isomer just say these are compounds with the same molecular formula, a different structural formula. Isomerism, the existence of compounds having the same molecular formula but different structural formula. So that is now isomerism. Then maybe I might be forgetting, though this topic is so, because we normally have what you call how to prepare preparation of alkanes, and also the occurrence of where these alkanes can be obtained, occurrence and extraction of alkanes. So this one is now a simple thing that you need to know. Maybe you might be asked where we can get methane. Methane is obtained from natural gas or crude oil. The main ore of methane is crude oil. crude oil or natural gas or a biogas. So that's now the sources of these alkanes. You can obtain alkanes from crude oil and biogas. Take note of that one. Take note of that one. Crude oil, natural gas, and biogas. That is where you can get these alkanes. So as the carbon chain increase, the boiling point or viscosity is of low or density also increases. Also flammability decreases as the chain gets longer. So you might be asked preparation of alkanes. Preparation of alkanes. We also have physical properties of alkanes and also chemical properties of alkanes. Now, I don't want to get much into preparation of alkanes because that is also another key area where you will get some questions. So I want you to refresh your minds first so that when I come in the next lesson, I will now finalize on lab preparation of alkanes, and also I will now talk about the physical properties of alkanes and finally chemical properties of alkanes. Then alkanes will be over. Then we go to alkenes. Thank you for watching. Keep subscribing. My name is Jacob. Thank you.